Alright guys, welcome back. This is 3.3 Graphing Linear Functions Part 2. My last video got cut off. I'm not entirely sure why. So we left off at graphing a vertical line. And we explained why the line is vertical and what its slope is. So same thing applies for a horizontal line. A horizontal line is written as y equals b, which just means some number. This will be a horizontal line and the slope will be 0. The slope will be 0 because when there's no up or down movement, then the slope is 0. And again, we'll talk more about slope in the next section. So y equals 4 just means that everywhere, every ordered pair I have in this equation, y is going to be 4. Well, what is x? X can be anything. X could be -4, it could be 0, it could be 2. Okay, so if I were to graph these points, -4, 4, that would be right here. 0, 4 would be right here, and 2, 4 would be right here. If I connect those dots, then you can see that we have a vertical line or a horizontal line at y equals 4. Now this is for exactly the same reasons that I explained in the previous video, 3.3 part 1, as to why this is a line even though there is no other variable. Okay, so if x is -6, then x is always -6. I'm going to go to 1, 2, 3, 4, 5, 6 and say, well, x is always going to be -6. So I just want to memorize or understand that a horizontal line is y equals a number and a vertical line is x equals a number. A lot of people confuse these because this is the x-axis and they want x equals a number to go the same direction as the x-axis, but it doesn't. It means that every x value of that line is the same, and for that to be the case it has to be a vertical line. Same thing with y. They want y's to go vertical, but they don't. They go horizontal because every point on this line has the same y value, and that's what this says. No matter what, y is equal to 4. The other coordinate can be anything, but y will always equal 4. Okay, so that is vertical and horizontal lines. The next part of this section, we'd like to just, I'd like to go over graphing. A couple of equations. First one is going to be, we're going to do this using slope-intercept form. And remember that we can substitute the f of x for y. So slope-intercept form says y is equal to mx plus b. Again, this slope here and intercept we're going to talk about. So the slope, what it does is it tells me where I'm going. Okay, and I like to think of this as when you walk into a mall or some big shopping center and there's this sign, you know, and it says, has this like map, and it says like, star, you are here, right? So this is how I like to think of slope-intercept form. This you are here point is this point right here. It's the point 0 and whatever that b value is. So if I have y is equal to, let's do the f of x, which is the same thing as y. So let's say the f of x is equal to a -3/4 x plus 1. Well, right here, this is my you are here point. This is the point 0, 1, because if I substitute 0 right here, then f of x, or y, is 1. So this is my x value is 0. When my x is 0, my y is 1. So this is my you are here point. Okay, that's the way I like to think of b. It's the you are here point. Then my slope tells me where I'm going. So you're like, oh, I want to go to this store that's like right here, right? So if you're going to go to that store, it's going to say, oh, okay, well, walk this way, then walk this way, then walk this way. Okay, that's what slope tells you to do. It says from my you are here point, where am I going? From my you are here point, where am I going? So if I were to look at this equation, it would say start at the point 0, 1. So that's right here. And from here, from my you are here point, where am I going to go? Well, from there, I'm going to go whatever this means. Well, this means down 3. So this top number always tells you up and down. Okay, so the top always says up or down. If it's positive, you go up. If it's negative, you go down. And the bottom, you just always think of it as right. Okay, and we'll talk more about slope again in the next section. So this is going to be down 3 and right 4. So from right here, I'm going to go down 1, 2, 3 and right 1, 2, 3, 4. So this is my next point on this line. From there, I'm just going to connect these dots. Okay, so this is how slope-intercept form works. Again, we'll talk more about slope in the next section, so this will become a little more clear. Let's graph one more in slope-intercept form so we can see how this works. Okay, so we've got, let's say we have the g of x is equal to 3x minus 5. Well, the important part here again is to figure out where I'm at, because I can't know where I'm going if I don't know where I'm at. So I am at the point 0, negative 5. So let's find that point on our graph. Okay, so that would be this point right here. And from here, it says I'm going 3. Well, I just said if the top is positive, you're going up, and if the bottom, but there is no bottom. The m right here is 3. But remember that any number divided by 1 is itself. So I'm going to think of this as 3 over 1. And because the top now is positive, that means I'm going to go up 3 and right 1. So from this point, my you are here point, I'm going to go up 3, 1, 2, 3, and right 1. 1, 2, 3, and right 1. So I can do it a couple times if I want. Slope stays the same. This rate of change on this line stays the same. Okay, so this is graphing using slope-intercept form. All right, so now let's do some graphing using the intercepts. So using intercepts, again over here, it means I'm going to plug in 0 for x and see what y is, and plug in 0 for y and see what x is. So our two examples here are going to be negative 2x plus y is equal to 4, and y minus x is equal to 3. Something I paused for and was thinking, oh, I need to say that. Let me say it real quick from the last example. You can only interpret this here as slope when you're solved for y, and I think I said this at the beginning of the other video. So looking at this equation, I can say, oh, the slope is 3, but right here, I can't say that the slope of this line is 3 because this is not in slope-intercept form. Okay, it's not slope-intercept form. So I have to either put it in slope-intercept form or use another method of graphing. Because this isn't in slope-intercept form, I'm going to use intercepts because that's going to make my life easy. But just make sure that you don't try to use this coefficient as slope. Okay, so what I'm going to do then is I am going to use plug in 0 for x and see what y equals. Well, that goes away, so it literally says that when x is 0, y is 4. Great, so that's one point on my line. Now I'm going to plug in 0 for y, okay, and see what x is. So we've got negative 2x plus 0 is equal to 4. Well, plus 0 is nothing, so I need to divide both sides by negative 2, and I get that x is negative 2. Well, x is negative 2 when y is 0. So those are my intercepts here. And let's see if we can figure out which one is which. Okay, so the point 0, 4 is going to be, I move 0 in the x direction and I move 4 in the y direction. Okay, and then I'm going to move -2 in the x direction, but 0 in the y direction. So this is what my line looks like. You can see here that this point is the point where we cross the x-axis. That makes this our x-intercept. Okay, and this point here is where the line crosses the y-axis. That makes this our y-intercept. So we have our y-intercept when x is 0 and our x-intercept when y is 0. Okay, so go ahead and pause the video and try graphing this one on your own. And when we come back, I will go through it. Okay, so here again, I'm going to plug in 0. When I plug in 0 for x, then this literally goes away and it says y is 3. Great, that's easy. And now I'm going to plug in 0 for y and see what x is. So a lot of people are like, boom, that goes away, and then they write 3 here. But that would be a mistake. Don't do that, because this is not x, this is -x. So to make it x, I have to divide by a -1. And x then is actually -3 when y is 0. Okay, so what does this look like then? I'm going to go to the point 0, 3, which is no movement in the x direction, but up 3. So that's my here point. And then I'm going to go to -3, and that is right here. -3, 0. And we'll connect those dots, and we have now graphed that line using the intercepts. All right,